All right, let's discuss topic 3-4A. We're going to be talking about the basics of triangles. So here we're looking at the principles of triangles. Okay? So a triangle is a polygon with 3 sides. Okay? You're going to draw it. Imagine that. You're going to draw it. It's kind of weird right there. Let me straighten that line out.
So a triangle.
Obviously.
That triangle was probably about as straight as some of you drive.
I can't
I drive
drive.
pretty good.
Is that driving straight
I-
line? Driving my ass close.
And,
Hashtag good driver.
okay, polygon with 3 sides. So when we make up the components of the triangle, the vertices are going to be the 3 points on the triangle. So P, Q, and R. Imagine that.
Oh, my tummy.
It's very complicated. P, Q, and R. So the vertices are any of the points. Think of it this way. Remember when we had the vertex of an angle? It was the only point at the inside of the angle. Okay? So the vertex of the angle was this. So here we have 3 different angles. 1 angle, 2 angles, 3 angles. Okay? So each vertex of the triangle is a vertex actually of an angle. Okay? The sides are 3 lines. Why? Because there are 3 sides, 3 lines. P to Q, P to R, and QR. So line PQ, line PR, line QR. Okay? And then finally, the angles. We have 3 angles here, like I said, angle P, angle Q, and angle R. Okay? Those concepts become very important to us when we talk about triangles. For example, you remember talking about perimeter when you were in pre-algebra. Okay? Perimeter, when we talked about that, you added up all the sides. Well, how can you find the perimeter of something if you don't know how many sides it has? Okay? How can you tell me the interior angles? Well, the reason why they equal 180, we'll get to that later in the year because way we calculate it, but 3 angles equal 180. Okay? We're going to talk about then the different types of ways to classify triangles. Okay?
No.
There are 3 types: scalene, or no equal side, or no congruent sides. Remember the equal sign with the, some people call it the squiggly line. If you speak Spanish, you call it a tilde. Okay?
To today.
No congruent sides. So in other words, in this sketch, this side is different than this side, which is different than this side. Okay? Isosceles triangle has at least 2 congruent sides. So in other words, these 2 sides are going to be congruent. Now, I'm going to teach you something else about this. The angles opposite of these sides, so in other words, here's the side, so it corresponds to this angle. This side to this angle, these 2 angles are also going to be congruent. Okay? So you're going to have 2 congruent angles and 1 different one. Okay? This one at the top being the only one that's not. And then finally an equilateral triangle, all 3 sides are congruent. Now, if all 3 sides are congruent, what do you think that means for the angles? Very good, Mr. McFadden. All 3 angles are going to also be congruent.
So, the
Okay, so let's classify these 3 angles. Okay? Okay, so, okay, this one, equilateral.
Scaling.
Okay, this one, very good, scaling. And the final one, isosceles.
I saw her too.
I see how to spell that because I always forget. Okay, so 2 congruent sides, 1 not. No congruent sides, all congruent. Okay? So it says the sum of the measures of the interior angles are 180. They're always 180. When I add up the inside, they're never going to be 179, they're never going to be 160, and they're never going to be 200. They're always going to be 180 degrees. Triangles can also be classified by the measure of its interior angles. So for example, these definitions. An acute triangle. All the angles are less than 90 degrees. So in other words, all three angles are going to be less than 90 degrees. So for example, if I had one that was 89 degrees and another that was 11 degrees, and then that would make the final one would be 70 degrees. Okay? Obtuse angles, it's a triangle. We can abbreviate a triangle this way with one obtuse angle. So for example, an angle that looks like this. I got two smaller angles here, but this one is obtuse. Remember, obtuse means that it's greater than 90 but less than 180. A right triangle. Right triangles will become very, very, very important to us as we go forward in geometry. In fact, they might become probably the most important angle that you ever deal with. Okay?
Right angle?
The right angle. It's called a right because it has one right angle in it. So the right triangle has one right angle in it. Okay? Those are going to become very, very important. In fact, we're going to end up having special types of triangles that will become absolutely crucial to everything you ever do in math for the future that ever deals with a triangle. You'll deal with them a lot, especially in the second half of the year. Okay? And then finally, equilateral is just like equilateral, except in this way we're talking about all the angles are the same.
They're all 60 degrees.
Precisely. Very good. They all have to be 60 degrees. Why do they all have to be 60 degrees?
Because they're all
Well,
congruent.
because it's 180 divided by 3. Because remember, the sum of my interior angles is 180 degrees, right?
Yeah.
So if I have 3 equal ones, I'm going to divide that 180 by 3, and that's going to give me 60. So taking a look at example 2, let's classify these angles. What's the first one? Equilateral. How do I know that?
Because they're all 60.
Because they're all 60 degrees. Very good. Okay? What type do I have here? Well, what type of angle is 75? It's acute. What is 85?
Acute.
What is 20?
Acute.
They're all three acute, which means this type of angle is?
Acute.
It's an acute triangle.
I knew it.
Okay? What type of angle do I have here? Is 35 acute or obtuse?
Acute. Obtuse.
What is 30? It's acute. What is 115?
Acute.
Obtuse. Okay? What angle do I have here? I just gave it away. Right angle. So I have a right triangle. Okay?
Not the whole half.
Yes, it is.
So, to sum up here, if I have all the angles are less than 90 degrees, I'm going to call it an acute triangle. If one angle is obtuse, which means it's greater than 90, that means I'm going to call it an obtuse triangle. If one angle is a perfect 90 degrees or a right angle, I'm going to call it a right triangle. And like I said, those are going to become very, very important to us in the future. And equilateral, also going to be important to us. They're all equal, and they're all equal to 60 degrees. Okay? Let us turn the page to example 3. Find the measure of the third angle of a triangle if the first measure is 66 degrees, the second measure is 37 degrees, We don't know what the third is. Now, what do all the angles have to equal up to?
180.
Very good. So I don't know what the third one is, so I'm going to say that's x equal 180. Can I solve that pretty easily?
Yes.
Okay. 66 and 37 are
R.
103.
103.
Okay.
Subtract.
Very good. I'm going to use subtraction property. And x equals what?
77.
Very good. 77 what? Degrees. Okay? Very, very, very simple. Okay? Now, using in example 4, it says find the measure of each angle in RST. Okay? So, RST, now what do all the angles equal up to?
180.
Very good, 180. So I'm going to take 3x plus x plus x plus 40 equals 180. Before I solve, I need to do some combining like terms here. So 3x plus x plus x. How many x's do I have?
4.
3 plus 1 is 5. That's a lot of x's, I'm just saying. Feel sorry for that person.
How many you have?
Plus 40 equals 180. Okay, what should I do next? What property do I need to utilize here?
Division. No,
Distribute.
subtraction.
Subtraction, very good. Because I'm going to subtract 40 from both sides.
44.
Get your x's by themselves. Now here I look, I have 5 x's all grouped up together, and that's never good when you have 5 x's in one place.
No, sir.
So I need to get the x's by themselves, so what do I need to do?
Divide.
Division property. X equals what? 140 divided by 5 is 20.
4.
Very good, 28. So x equals 28. So now, I'm not done yet. I need to find the measure of these 3 angles. So the measure of angle R is 3 times x, which means I have measure of angle R is 3 times 28. Which means measure of angle R is 84. Measure of angle S is x. Do I need to do anything extra there?
No.
Nope.
No, I just write down my 28.
28.
And then angle T is x plus 40, which means I have 28 plus 40, which means I have what?
68.
68. And I like this. That makes me happy.
I like.
Okay? Okay. So first of all, what kind of triangle does it look like I have here? Tell me about, it says x, x, and x.
Equilateral.
Okay, equilateral, and it's also a what?
A cube.
Not a cube. Well, yes it is. You're right. It's going to be a cube. But what else?
Oh, watch out.
So it's going to be, they're going to be congruent. They're going to be equilateral and equal. We said equilateral. What else? Equal angle. So in other words, equal sides and equal angles. So if I have this, what are the interior angles of a triangle again? They are
180.
180. Okay? So I have 3 x's here. X plus x plus x equals 180. I have 3x equals 180. Divide by 3. Divide by 3. X equals 60. So the triangle in example 5 is an equal angle triangle. Based on this example, we can say that each angle of an equal angle triangle is 60 degrees.
So if we'll touch something, they have to
On a test, if you can recognize that it's an equal angle triangle and you remember that it's 60 degrees, no, I'm fine with that. Okay? But that's an important principle. Now let me ask you this. Is an equal angle or equilateral triangle, are they ever going to be different than 60 degrees?
No.
No.
I just measured standards of this and gave
Okay.
it a stern.
All right. Oh, cool. So this is fun. Let's take a look at this one. What type of triangle do I have here, folks?
Right angle.
I have a right angle, which means I have what type?
90.
I have a right triangle,
What?
which means, yes, I have 90 degrees. Awesome possum. So I need to solve for x. What are the sum of my triangle angles?
180.
180. Very good. So I'm going to take my 3x plus 2, and then I'm going to say, hey, 2x plus 3, let's join them. And then I'm going to add my 90 since I've got a 90. Okay? And I hope all of you have a 90 in this class.
I'm pretty.
Okay? Combine like terms. 3 and 2 are 5, x. 2 and 3 are 5,
9.
plus 90 equals 180. It gives me 5x plus 95, combine like terms, equals 180. Which means I subtract 95, subtract property. Gives me 85 over here. Divide everything by 5, so now I've got 5x equals 85. Divide by 5. And x equals what?
15.
How much?
1.
17. Okay, so let me review what we did here. Okay? Let me review here. We notice that we have a right triangle, which means that one angle has to be
90 degrees.
90 degrees.
100.
One angle here has to be 90 degrees, which means that all of them together plus 90, so these two plus 90 equal 180. Which means if I add them up together, combine like terms, subtract, then divide, I get x equals 17. So angle J and angle L, it says, angle J and angle L, those are those two, would be classified as acute angles, since their sum is 90 degrees. We agree with that? Yes,
Yes, sir.
because they're both going to be smaller. We can say then that the acute angles of a right triangle are complementary. In other words, it just makes sense that if I have 180 degrees for all of my angles, and one of them is 90, then the other two have to add up to being 90. That just kind of makes sense. You know what I'm saying, Yo?
Yeah.
Okay? So, the exterior angle of a triangle, then, is formed by one side of the triangle and the extension of the adjacent side. The measure of an exterior angle of the triangle, to find the measure of the exterior, add the two remote interior angles. Okay? So, what they're saying is, so there are two ways that we could find this. First, you could find angle 2, then take the supplement of it to find angle 1, or what they're saying is you can add the two, up here it says 2 remote interior angles, so that means these two right here,
Then subtract.
and that's all you have to do. Let me show you how we get that so we can prove it. Remember, all three angles on the inside of a triangle equal 180. So that means some angle, which is this one, plus 80 plus 40 equal 180. Okay? That gives me x plus 120 equals 180. Subtract 120, subtract 120, x equals 60. Okay? So this angle here has to be 60. Then I see that the type of angles I have here is the linear pair type. Okay? Which means this entire angle from here to here, this angle plus this angle equal 180. You take 180 minus your 60 and you get 120. Okay? So that's showing you both ways of how you did that. But the shortcut here is that if I have an acute triangle, okay, or just a triangle in general, and I'm trying to find, and I have an angle out here outside of it, I can take the two angles that are furthest away, so the one that's not adjoining to it, it's not adjacent to it, and I can add them up, If I add those two, they gave me 120 degrees. And that makes me happy, happy, happy.
How much? How, Bandit?
Happy, happy, happy.
Happy, happy, happy.
That was a
All right. In example 8,
Thank you. Oh, you went too.
No, you don't.
in this triangle, let's get that up just a little bit more. All right. In example 8, triangle XYZ, the measure of angle X is 63 degrees. Okay? The measure of X, Y, and Z, so this angle,
What? Okay.
X, Y, and Z is going to be 53 degrees. Now they want you to find Z, Y, and R. Okay, so they want you to find this angle. What is this angle? Okay.
Are you ready?
What I'm going to do to solve for this is I'm going to take this angle right here and this angle, and I'm going to add them together.
Didn't work.
So 53 plus measure of Z, Y, and R equal 180. Okay? Subtract both sides by 53, and I get 127. Okay? That simple. So all I did here is I associated that these two angles, what type of pair are those from our angle pairs that we learned? Linear pair, very good. So these are linear pair angles, and they add up to 180. Therefore, I can just subtract them over. Okay? And for our final example, in this triangle, the measure of angle G is 100 degrees. F to E to H, so this angle outside is 3 times the measure of angle F.
Where'd you get 3? Oh, okay.
So this is interesting. We've never had one quite like this before. Okay?
Haven't we though?
So what did we just learn? We just learned, so this is the measure of angle F. We don't know what it is. We're trying to find it. Okay? Here's what's cool. Here's something we just learned from, turn the page over here. Okay? To find the measure of the exterior angle, add the two remote interior angles. So we have this exterior angle, so 3 times the measure, I'm going to change this right here, I'm going to call this X. So 3 times X equals, I'm going to add these two.
Pardon this interruption. It is still raining outside, so we're still going to have the buses running from here, from the main campus to the 9th grade. So please make sure you go to the bus pad and catch the bus there if you are going to the 9th grade.
Okay.
So make sure you go as quickly as possible so that you won't be left behind. Thank you.
Okay. So what I'm going to do is I'm going to say 3, if this is this angle is 3 times the sides of this one. So do you guys remember when we had those statements where we said, I think they were what, 1, 6, and 1, 7?
Yeah.
Where we said 3 times the supplement, 3 times the complement. Remember how we had to solve those? Okay. This is kind of like that. So we're saying 3 times one of the interior angles that are opposite of it plus 100 equals is what it is. Okay? So I have the angle plus 100 equals 3 times that angle. Right? So now what I'm going to do, subtract X. I'm going to divide by 2. and this equals 50 degrees. So, before you start putting things away, let me just explain this to you one more time.
Oh, okay.
Explain this to you one more time. Remember that this angle, based on what we just learned, this angle right here, this exterior angle, is equal to this angle, the two remote interior angles, added together. Which means that if I take the measure of angle F and I add it to 100, then in this case it equals 3 times the measure of angle F. Okay? All I did was I changed the measure of angle F to X. Okay? And then I solved for it with algebra.
I got